everybody, Dr. Rob here. I'm here with Dr. Nichola Conlon, superstar in the world of NAD. So, good day, good morning, good afternoon. How are you feeling today?
I'm good. It's the afternoon here. And for
Mhm.
you, what time is it for you?
It's about 12:20. Yeah, I think you guys are
Okay.
about 5 hours ahead in the UK than we are.
Yeah, yeah. Yeah, we are just after 5:30.
So, interesting. I was reading your bio, and I love the idea that you want to democratize science for everybody. You want to bring NAD to the forefront. So, it really begs the question, what is NAD and why is it important?
Wow, great question. So NAD is something that is naturally found in every single cell in our body.
Wow.
It is very important for hundreds of different reactions, but I guess the two things that it's most famous for are firstly energy production. So literally taking the food we eat and turn it into the energy that our bodies need to function, but also for cellular repair. So it seems that NAD drives a lot of the cellular repair pathways in our body. It almost acts as a fuel. So, as a general rule of thumb, all you need to remember is if you have lots of NAD, you have lots of repair and lots of energy. But if NAD goes down, then you have less energy and less repair in your cells.
Now, what's interesting about NAD and NADH, can I add the H to it? Would that be correct?
Yeah. So they flip between the two versions. So sometimes you'll see NAD called NAD plus, which is its oxidized form, and sometimes you'll see it NADH. And this is because it's the way that NAD works is it flips between these two states. It loses and gains electrons. And that's very important in something called the Krebs cycle, which is what NAD is used for in energy production. It's literally constantly losing and gaining electrons in the electron transport chain that drives this energy production in our cell. So it flips between two states. The state that we are a lot more interested when it comes to aging and longevity is the NAD plus state. Because as we get older, it seems like our ratio of NAD plus to NADH starts to shift. And you get more NADH, less NAD plus, and actually you want to tip it back in the other direction.
So it's kind of like a cycle pathway. You may use too much, that's actually very detrimental to one's health. You use more, and it's more beneficial. So how does this fall? You mentioned it, and it really begs the question, the conversation piece of 2024 to 25, longevity. How does NAD or NADH play in the idea of longevity for the common man?
So basically, like many things with aging, NAD declines and its decline is pretty exponential. So when we're young, we have a lot of NAD. We're born with high levels of NAD, but it halves around every 20 years. And this is from birth. So even by the time you're 20, you've lost half your NAD. By the time you're 40, this amount is halved again, 60, halved again. So if you look at it on a graph, it's a real exponential decline. And, considering how important I've just told you it is, it's in every cell in our body. It's driving critical energy production pathways and also repair. It means that as it plummets, as we get older, we start to get a lot of damage in our cells. And this manifests as a lot of the signs and external symptoms that we see and feel as part of the aging process. But then also energy production goes down and we start to feel tiredness, fatigue, brain fog. Again, all of those things that are associated with common aging symptoms.
So the decline is an issue, but obviously the reabsorption is a positive, so much so that could we say that the proper level of NADH or an improved level of NAD will turn back will turn back the chronological clock and advance the biological clock?
So basically, it's known that this decline in NAD is linked to cellular aging.
Mm.
So, scientists said, okay, we've got this really important molecule and it's doing all these beneficial things. And as we get older, it declines and it causes all this chaos in our cells. So, can we actually boost NAD levels back to youthful levels? Or can we actually just keep NAD levels high and stop them declining as we get older? Will that actually mean that we keep all of the repair switched on, keep youthful energy production switched on? And to cut a very long story short, now there are hundreds, if not thousands, thousands of scientific studies that show that by boosting NAD, you impact cellular health. More specifically, it actually helps to benefit what we refer to as the hallmarks of aging, which are the 12 key processes that seem to be driving the entire aging process in our cells. So when NAD is high, the hallmarks of aging become better, essentially. And when NAD goes low, the hallmarks of aging seem to get worse, and it drives the aging process. So NAD is exciting because it's usually you wouldn't find that one molecule has such a profound benefit across all the hallmarks of aging. Usually like one molecule and impact one hallmark, another molecule for another hallmark. But NAD is exciting because it seems to have a benefit for all of the hallmarks of aging.
So let's go through some of the hallmarks of aging. There was a 2013 study in the hallmarks of aging. A follow-up 10-year study was released in 2023. So I'll take a couple off the 2023. Dysbiosis.
So dysbiosis is just, a chronic state where looking at our microbiome, whether it's our gut microbiome, our skin microbiome, there's got to be a very careful balance, between, I say, the good and bad bacteria, but also the diversity of bacteria. And what we see as we get older is that we get an imbalance towards bad, and also the microbiome becomes less diverse. And we know that a lot of these bacteria have a symbiotic relationship where, we are benefiting them, but they are benefiting us. And when you start to see things like dysbiosis, that actually then has knock-on impact across the whole body in terms of driving things like inflammation. And that is a second hallmark of aging, this idea that we have chronic low-grade inflammation. And this was one of the hallmarks that was actually, well, both of these were added in the most recent edition of the hallmarks of aging. Chronic low-grade inflammation is like this smoldering fire in our bodies that is just burning away and damaging our cells. We know inflammation is a good thing under the right circumstance, but not when it doesn't get turned off properly and it's just constantly burning away. And inflammation is so damaging to the health of our bodies and our cells.
Yeah, for me, inflammation, it's my credo to manage and modulate inflammation, and it's chronic inflammation. Well said. One of the newer hallmarks of aging also was issues with autophagy, which is typically the breakdown of old cells, use the debris to make new cells. How does NAD work within the framework of autophagy in that process?
So NAD basically is something that is naturally triggered to be made in our cells. So a key thing to probably highlight is that NAD is not something that we get from the diet. It's something that our cells produce. We have a pathway in our cells that makes and recycles NAD continuously so that it's always available. Now, there are a couple of things that will turn on that NAD production. And those things that turn it on are typically when our cells are in a little bit of a stressed state. So things like if we have an energy stress, so if we are fasting or if we are, exercising intensely, these things trigger an alarm bell in the cell to say, oh my goodness, we have a bit of stress going on here. We need to up energy production. We need to up repair and recycling to make sure our cells get through this period of stress. Bearing in mind the fact that maybe no new nutrients are coming in, we may need to recycle and renew things. So this NAD production pathway literally gets turned on. The enzyme in our cell that creates NAD literally comes into action. It starts producing NAD. NAD is there for the mitochondria for energy production, but it also goes off and turns on all of these signaling pathways. And one of the things that NAD is known to work really well with or switch on in the cell is a group of proteins called the sirtuins. And the sirtuins are very famous in the longevity world. They're often called the longevity genes. And when these sirtuins are switched on, they activate lots and lots of different downstream pathways. But one of the things they do activate is autophagy, cellular recycling. So again, it's like this sort of action plan by the cell when there's any stress to really quickly switch on lots of different repair processes. And, recycling, autophagy is a good one because it means that you're not only repairing damaged parts in the cell, but you're also releasing parts to be recycled and reused for something else when there is a nutrient scarcity or an energy scarcity.
it has been stated that longevity is turning on the health switches. I purport to you that the master switch of health and longevity may be turned on by the proper production or the efficient production of NAD.
Yeah, NAD seems to almost sit at the top of almost like an umbrella of downstream pathways. Once the NAD goes up, because it interacts with so many different things in the cell, so many different positive pathways, that as NAD goes up, it's a very quick way for the cell to switch on lots of beneficial pathways. So as NAD goes up, you see autophagy switched on, you see repair, DNA repair proteins switched on, you see things like NF-kappa B, which is a key driver of inflammation, actually turned down. So it's a very quick and easy way for the cell to just, have a mass switch on of cellular health processes.
Great stuff. I did some reading on NAD. We had met in London, and you really turned me on to really needing to know more about NAD. But I understand a decrease or a lack of NAD is big in Alzheimer's, diabetes, and many other, if you will, autoimmune conditions. So I'm going to read something to you, and then I'm going to pass the baton. A major pathway of NAD biosynthesis is the salvage pathway from nicotinamide. And then it goes on to say nicotinamide is converted to NMN, a key NADH intermediate, by NAMPT, the rate-limiting enzyme in this pathways. Then NMN is converted to NAD plus or NADH. Make sense of that for everybody. I know I just gave you that salvage pathways. People are going, oh, he's at it again. So help me out.
So basically, as I mentioned, our cells make all of the NAD that they need. And it's actually a really clever system. So as NAD is used up in the cells, so if it's used for things like DNA repair or switching on the sirtuins, what happens is that big NAD molecule literally gets split apart in the process, and it gets broken down into one of its precursors. A precursor is like a building block for NAD, and it gets split down into nicotinamide. So this nicotinamide then starts to build up in the cell. So the cell then literally scoops it back up in the salvage pathway and converts it back into NAD again. And NAMPT is like effectively the machine that does that. So if you think of a cell as a factory that's producing NAD, you've got these NAMPT machines that are looking for all the raw material, which is nicotinamide, turning it into NMN first, then into the big NAD molecule. So NMN is like an intermediate step, but the end goal is NAD. So effectively, your cells have this amazing capacity, which is whereby if NAD use goes up, it means that it's more NAD is being broken down. So more nicotinamide is then available for the cell to then make into more NAD. So it's like a very clever way for the cell to always basically address the demand for NAD, because the raw material should always match the demand. But this is actually where the problem with aging starts and NAD decline. Because for a long time, we knew that NAD declined, but we didn't really, understand why. Like, why was it going down in our bodies? But we now know that one of the main drivers of NAD decline with age is the fact that this pathway, this salvage pathway, doesn't function as well as we get older. And the reason it doesn't function is because NAMPT, as you mentioned, is a rate-limiting enzyme. And that enzyme declines with age. And that is the sort of, the real critical part, that if that goes down, the whole production pathway starts to fail. So NAD declines because our bodies become less good at making and recycling it.
Interesting. Great stuff. Thank you for translating that science into tangible, understandable information. So you put together a formula that has about 6 to 8 different ingredients to allow efficient NADH or NAD plus production. Would you like to go through each one of those ingredients and let everybody know why you chose them?
Yeah. So what we wanted to do was develop something that targeted the root causes of NAD decline. So, I've just mentioned that one of them is the fact that we start to see a reduction in this salvage or the recycling of NAD. But actually, that isn't the only issue. There's actually a couple of other things that are also going wrong in the cells. The other thing is chronic inflammation, which we've already discussed. We know that as we get older, we suffer from chronic low-grade inflammation. And if you were to look on the actually on your cells in older people that are chronically inflamed, you would see another enzyme called CD38. And CD38 is a prolific NAD consumer. So it uses huge amounts of NAD as fuel to drive inflammation. So not only do we have a situation where NAD production and recycling has gone down, but in older cells, we also have this inflammation that's using way more NAD. We've also got a lot more damage, which is using NAD as a fuel. And we also start to see problems with methylation. So if this recycling pathway isn't working well, the nicotinamides and the precursors in the cell start to build up because they're not getting recycled. This NAD is being used to drive inflammation. It's being used to drive repair. It's getting broken down into nicotinamide. Then the nicotinamide's building up because that pathway that then scoops it back up and turns it into NAD, that declines. So already you can see there's quite a few things that are going on that need addressing. And when we looked at the products on the market, the most famous one being NMN, which is a precursor to NAD, they effectively ignored all these issues. They were, again, thinking of the factory analogy, they're literally saying, okay, we can see in the factory that the machines are broken, the pipes are leaking, the staff have left, there's all these problems, but we're going to ignore all that and we're just going to order more raw material because NMN is effectively a raw material. And what you see is that it actually makes a lot of these problems worse. The NMN seems to now be driving inflammation because CD38 will grab any NAD before any of the beneficial things like the sirtuins or anything like that even get a look in because it has a much higher affinity for NAD. We see methylation problems increase with these products because, again, you are putting all this precursor into the factory that can't turn it into anything. So it starts to build up. And the way that our bodies actually get rid of this precursor is to methylate it. So it puts a little methyl tag on and chucks it out of the cell. So then you have a situation where you think you're doing a good thing to top up NAD, but actually you're driving inflammation and you're actually causing methylation issues by using all these precious methyl groups on things that it's not supposed to be used on. So everything in our product is designed to do things very differently. It's designed to look at all of those little points on all of these pathways that are going wrong and fix it. So when you say about the ingredients, the first place to start is, a key thing that has to be fixed is the root cause. And that is this enzyme that declines with age, NAMPT, the key rate limiting enzyme in the salvage pathway. So we actually have two different ingredients in the product that are designed to switch this back on. The first one is rutin, and this is from a flower called Sephora japonica. And not many people might have heard of this ingredient, but what you probably will have heard of is something called quercetin or quercetin, depending on which accent you pronounce it in. But this is an active ingredient that actually directly activates NAMPT. And this is an active molecule that's found within the rutin. And a lot of people say, well, why don't you just use pure quercetin? Why do you use rutin? But rutin is much better absorbed than the actual quercetin molecule. So rutin is a quercetin glycoside, and this actually protects it as it goes through the gut and the stomach. And then the actual active molecule of quercetin is cleaved off, and then it goes to the cell and does its job. So that is one of the ingredients that we know turns back on this enzyme. Alpha lipoic acid is another ingredient that actually does this as well, but it works via a slightly different pathway. The way alpha lipoic acid works is it activates a cellular sensor called AMPK. And AMPK acts like an energy sensor in the cell. So earlier I mentioned that if you have any energy stress, an alarm bell goes off and switches on NAD production. This is AMPK. And alpha lipoic acid naturally switches this back on. So those two ingredients are very targeted towards switching back on this natural pathway that is making and recycling your NAD. And we proved this in a clinical trial that it actually does this.
So by using ingredients that turn on a sirtuin pathway, a longevity pathway, turning on the health switch, and an AMPK pathway, the end result is more efficient production of NAD, or is it NAD that turns on these pathways, just for clarity?
So AMPK turns on NAMPT, which is the enzyme that produces NAD.
There you
It
go.
switches back on the machine in the factory. So ALA, the molecule, where that comes into it is it mimics that energy stress. So rather than doing the exercise or doing the fasting, ALA kind of, bypasses it and just switches on that switch anyway. So those two ingredients switch on NAMPT. So they are fixing the machine in the factory effectively. The next ingredient that's really important is something that actually inhibits the chronic inflammation. So as I mentioned, CD38 is this huge drain on our NAD supply. And if you can inhibit CD38 even a little bit, it has a massive impact on preserving NAD. So we actually use parsley for this. And again, people are like, parsley, that's very odd. Like, why is that in there? And what has that got to do with NAD?
Question.
But the reason we use parsley is parsley has an active ingredient in it called apigenin.
Mm.
And again, apigenin's shown in many studies to inhibit CD38 and in turn boost NAD levels. But again, when you look at the oral bioavailability of apigenin, although many companies will be saying, oh, yes, we have pure apigenin, it doesn't get absorbed. But if you use it in the whole food format, it's absorbed very well and it actually gets to the cells where it needs to have its function. And I probably should point out that the reason I'm so fussy about, absorption is my PhD was actually in the bioavailability of nutrients, drugs, supplements.
Mm.
So I have a very big frustration with a lot of the supplement industry when it comes to bioavailability because they lead consumers to believe that these raw active molecules are the best version, but actually they don't exist like that in nature and they are not absorbed like that. So often using a more whole food format of something leads to way better levels in the blood of the molecule that you're actually interested in.
Interesting. Great stuff. So you had a few other ingredients I was curious about. Vitamin C, zinc, black pepper, fruit extract, all coenzymes.
Yeah, so the vitamin C and the zinc, they do have multiple benefits in the cell. They are not directly linked to the NAD production. They are more cellular support, antioxidant support in there as well. The black pepper is actually to help with absorption. So again, this is a bioavailability thing. Black pepper contains piperine, which helps with the absorption of multiple different active ingredients. So that is why that is in there. The other ingredient to point out is the green tea extract. And the reason we're interested in this is for a compound that it contains called EGCG. And that is just a super powerful ingredient. But the reason it is in our product is because you remember I was talking about the methylation issue? Well, as we start to get these methylation problems as we get older, again, you start to see all these different enzymes start to get switched on that shouldn't be. And one of them is a methylating enzyme, and this is called NNMT. So we have all these crazy acronyms in science, but this is NNMT. And essentially what this enzyme does is once the nicotinamide starts building up in the cell, this enzyme gets turned up and it literally comes and it sticks a methyl group on the nicotinamide and tells it to be excreted. And again, you see in older people that have all these methylation issues and chronic inflammation that this pathway, this enzyme is way overworking. And it means that all of that precious nicotinamide that should be getting turned back into NAD is actually getting chucked out the cell. So again, yes, you can improve the salvage pathway and the recycling, but you need to make sure that that's also turned off to make sure your factory workers aren't just chucking all the raw material out the window. And EGCG, it does exactly this. It inhibits this enzyme. So that is why we have that in the cell, in the product.
EGCG, without question, is a universal health promoter.
Oh, yeah.
Great choice. So the begs the question. I had some people I spoke to, and I said I was talking about NAD specialist, Dr. Conlon, and they were like, ask her the question. I'm going to ask you the question. Resveratrol, longevity nutrient. Agreed?
So resveratrol is an interesting one. First of all, there's, it's classified as a sirtuin activator.
Mhm.
So the controversy over resveratrol is, we know it does activate the sirtuins. We know, that there is evidence for that. Bioavailability is a big issue. It's again one of these things that is not very well absorbed. So bioavailability is a big issue. But actually, there's a lot of conversation surrounding resveratrol, but you can activate the sirtuin as much as you want. But if you don't have NAD to power the sirtuins, it does absolutely nothing.
Mm.
So before you are even thinking about anything else to try and activate the sirtuins, you need the fuel. It's almost like, again, like thinking of an analogy, the NAD is like the fuel, and
Mhm.
then the resveratrol is like the turbo booster on top of that to give it the edge. But you absolutely have to have NAD there. Without NAD, the sirtuins do not function. The NAD is a fuel for the sirtuins.
So it's Veritrol on its own, but for longevity, but not necessarily for NAD efficient production. Would that be?
So resveratrol does not impact NAD production. Resveratrol is entirely separate. The link between resveratrol and NAD is the sirtuins in the middle. So
Okay.
you've got the sirtuins. Resveratrol acts like as an activator. It improves the efficiency. So sirtuins are like an enzyme, and it improves the efficiency of the enzyme. But the fuel for the enzyme is the NAD. So there's no point in improving the efficiency of it if you don't have the fuel. So actually, the most important thing first is making sure the NAD is there.
Excellent. So I always try and do on every podcast, we call it like fun facts, like rapid fire. So I'm going to ask you a couple of questions and we're going to give and hope that we get a Jeopardy type answer from you. Number
Okay.
foods to stimulate NAD.
Oh, I mean, actually, food doesn't stimulate NAD. Food inhibits NAD production. If you eat, your body thinks, oh, there's no energy stress. We can turn NAD production down. So actually, no food for better NAD.
That may pose a problem. Okay. Exercise. Yes, no, and what kind?
Yes. Exercise has been proven to naturally boost NAD production. It's been shown in both high intensity interval training and also in weights training, so in resistance training as well. Both types work by switching on NAMPT and boosting natural NAD production.
Outstanding. Intermittent fasting.
Again, great. This is the no food situation. When you put your body through a period of energy stress, this is again, it naturally increases NAMPT. There's a lot of controversy over how long people should fast. It seems that men need a bit longer than women, but in general, fasting is a beneficial thing to switch back on NAD production.
Number one ingredient to aid in NAD production.
Nicotinamide. So there's a lot of, fuss over all sorts of different precursors like NMN or NR or, which is the best precursor. But actually, nicotinamide, which is a simple vitamin B3, is the body's preferred precursor to make NAD. That is what our salvage pathway uses. It uses nicotinamide. That is what NAD is broken down into. But the most important part is, again, back to bioavailability. Nicotinamide or niacin, it has multiple different names, is the one molecule out of all of these different precursors that is freely bioavailable. It's absorbed into all cells. It freely enters the cells. Whereas NR or NMN, they actually need, again, special transport channels to get in. So they don't actually access a lot of the cells in the body.
How do you test for your NAD levels?
So NAD is something that can be measured in a lab. It's a fairly simple thing to measure. But what is not simple is getting your blood drawn in a doctor's office or doing it at home because NAD is very unstable, which means that any blood sample that you want to measure NAD, you literally have to have the person in the lab pretty much because, within minutes, the NAD starts to degrade. And up until now, I've not found a company or a kit or anything, despite what a lot of people say, that have worked out a way to stabilize it and, send it off in the post. Hopefully there will be something like that in the future. What I would recommend as a surrogate is looking at levels of inflammation or looking at something like biological age because these things are more stable.
Which conditions have you found attenuated best from increasing NAD levels?
anything that has a problem with a mitochondrial dysfunction. So, in terms of how that would feel for a person, that would be things like real fatigue, chronic fatigue syndrome, anything that is damaging to the mitochondria, Lyme's, COVID, or anything that has an element of fatigue, and that could be physical fatigue, but also cognitive fatigue. So brain fog is a massive thing that seems to, we get so many customers saying, oh my goodness, like I didn't realize how bad my brain fog was until it's not there anymore. And it literally is like a cloud's being lifted. In particular, huge feedback from perimenopausal and menopausal women. We know that, a lot of the energy problems, the brain fog that they suffer is because of the link with estrogen and the mitochondria and mitochondrial dysfunction. So, NAD is coming in and trying to help fix part of that problem.
I am going to piggyback on what you said on NAD and mitochondria. There's 4 complexes that need to be stimulated to have efficient ATP production in the mitochondria. Complex 1 and 2 are stimulated by one ingredient and one ingredient only or mostly, called NADH or plus, as you said. And then when you get from 2 to 3, you're looking at coenzyme Q10. So if you're suffering from fatigue, if you're suffering from mitochondrial dysfunction, most neurodegenerative diseases have a definitive parallel with mitochondrial dysfunction, you're going to benefit from stimulating the efficient production of NAD, NADH. That said, last question, you mentioned methylation. Gary Brecker said that we need to test to see if we have a methylation gene. That's sort of wrong. We want to see if we over or under methylate. That would be a little better. But would you recommend someone taking a methylation gene test to determine your efficiency of NAD production?
Yeah, so it is all linked. And especially, anybody who is a poor methylator definitely doesn't want to be taking things like NMN because that is going to drive the methyl groups down even more. And actually, that is where, taking this approach that we have, where we're actually dealing with the methylation issues and not letting that drive methylation down even further is so important. Again, you'll hear a lot of people saying, oh, well, I've been told if I take NMN, I have to take trimethylglycine alongside it because you get this methylation problem. And for me, it's just crazy. It's like back to the whole drugs problem where it's like, you take one drug, then you have to take another drug to fix the side effect of the first one. Like that's starting to get into that kind of system with supplements because people are not fixing the root cause. They're just putting more raw material in there. So yeah, looking at methylation is important and definitely making sure you're targeting the right things to not make any methylation issues worse.
Outstanding. Now, you've also created a company that makes a product for NAD, but you also have a theme behind it. It's a whole system science. You want to explain that a little bit? Because I'm really excited about that. I love all interconnection, whole systems, looking at the body as one functioning unit in sync.
Oh yeah, this is something that's so underrated. Often in, science is complex. Well, should I not say science? I should say biology is complex. There is nothing in biology that exists in isolation, but unfortunately, especially in the medical system and the drugs development system, even we have this idea that we can target, there's a disease or there's a problem and there's this one gene or this one enzyme that's causing this whole problem. So let's target that one thing with one molecule. And quite often it doesn't work because the reality is that our biology is super complex and it's never just one thing. There are multiple things. They're all interlinked. So if you really want to have an impact on anything in physiology, you need to look at the bigger picture and you need to look at the multiple things that are all speaking to each other and all interplaying and actually target multiple things. And, the perfect example is what I explained earlier with our product. It is looking at all the different points that we know go wrong with age in the NAD network. And it's not just picking one and targeting that. It's actually looking at fixing all of them. Because if you fix one, for example, if you fix the salvage pathway, that's great. But if you still got that methylating gene turned up, all of the nicotinamide that's meant to be going into the salvage pathway is getting chucked out. So, you fix the machine, but then you've got no raw material. So, it's really important to look at everything to do with biology as a whole system, which is exactly why we say that.
Great stuff. I got some questions about your clinical trial data. I know you did one. I know you want to share that. As we always say, science is proof in the pudding. Well, so let me know how it all gelled together.
Yeah, so, very important for me was to get a good clinical trial done on the product. When I left my job in drug development to start a supplement company, everyone said, oh my goodness, like supplements don't work, only drugs can possibly work. And I really wanted to prove that wrong. But the only way to prove it is to really do a proper study, because there's a lot of supplements out there that just make all sorts of claims, but don't actually have the science to back it up. So we did a full double-blind, placebo-controlled crossover study, which in terms of design is a gold standard in clinical design. We also had a really diverse group of volunteers for this study. So usually for an NAD study or just any study to do with aging, you will take men only, and they will be between, usually 55 to 65-year-old, and you usually have some sort of metabolic disease, whether that's obesity, fatty liver. That is usually the group of people, because that is the group that you get the best result in, essentially, that have terrible NAD levels. So we didn't feel that very representative for a consumer product that's going to be targeted at a wider population. So we actually used men and women, and we used age from 20 all the way through to 80. So it was a much riskier trial, because you would expect in 20-year-olds their NAD should be, it's halved, but it's substantially more than a 55 to 65-year-old obese male. So it was a bit risky, but we wanted to have a study population that was actually representative of who would actually be using and benefiting from this product. So the study, we measured several different things. Obviously, the first was NAD. We saw that after 7 days, NAD starts to increase inside the bodies, and then it continues to increase over 28 days. So this study was for 28 days. Importantly, we didn't want to just show that it was increasing NAD, but we wanted to show that we were very different from other products by showing that this was actually switching back on NAD production. So it was fixing the root cause. So we measured levels of the NAMPT enzyme in the cells of these people, and again showed that there was a significant increase. So it's the first NAD product that's been shown to actually switch back on this enzyme and essentially boost NAD from within by switching on your natural NAD production. Aside from that, we then wanted to look at, okay, we're boosting NAD, we're switching back on NAD production, but what is this having, what benefit is this having on the cellular health? So we measured a number of age-related biomarkers. One was inflammation. We've already explained how important that is in aging, and we saw a reduction in inflammation. Another thing we measured was glycation. So again, glycation, it's when sugar molecules become irreversibly bound to proteins in our body with age, it causes them to stiffen. And this is a real problem in cardiovascular aging. So our arteries stiffen. Also in skin aging, it's stiffening of the collagen and elastin. And again, we saw a significant reduction in glycation. But I guess for me, the most exciting bit was we also measured biological age. And we saw that in 28 days, a reversal of biological age by 1.26 years. Okay. So for me, that was really exciting, because again, there are not many supplements out there that have actually proven to reverse biological age. And again, this is not a drug. This is a supplement, and that's accessible to everyone.
Great stuff. It's always, as you know, I mean, you're a scientist at first. When you're able to prove the product, it makes everybody feel more enthusiastic about the usage of the product. But the big topic now is IV injections, IV drips. Where does NAD play with an IV drip, and how does an NAD IV drip differ from oral ingestion?
Yeah, so with an IV, the issue that we'll have is it was thought initially it was a good way to boost NAD, because it's bypassing the gut. So NAD is unstable. It just gets destroyed in the stomach. It's not absorbed. So putting it in IV or injecting it kind of bypasses that and it gets it into the blood. But actually, NAD doesn't do anything in the blood. So as we mentioned, NAD is very important for the mitochondria, for DNA repair, for the sirtuins. All of those things are not in the blood. They are inside of the cells. And that means that the NAD from an IV infusion has to get from the blood actually into the cells. And because it's a large charged molecule, cells do not just let it freely go in and out. It has to have a special channel to go through. And the majority of cells in our body do not have this channel. So that means when you have an IV drip, the NAD is like suddenly a huge amount in your blood and then it's stuck there. And the body's like, oh, like we shouldn't have this amount of NAD in our blood. We need to start metabolizing it. So if you speak to anyone who's had an IV, they will say, oh, that was hard work. I felt sick. We had tight chest, heart palpitations. Not very nice because the body's having to massively work overtime to try and metabolize it. In terms of clinical studies, there's only been one clinical study done on an IV, which I still find crazy considering how long they've been around, how much people are paying for them, how much people are charging for them. And the one study that came out showed that all that NAD that people are paying, hundreds of dollars for is metabolized rapidly into precursors. And then it's the precursors that are smaller that are taken up, in which case you might as well just take a vitamin B3 and it's an awful lot cheaper. But, then the argument they give is, well, it's a good way of getting a high dose vitamin, B3 into the cells. It's better than oral. But yeah, you can put as much precursor in the factory as you want. But if you haven't switched on the enzyme, if you haven't dealt with the methylation, if you haven't dealt with the inflammation, it's completely pointless. And then it goes back to the same issues that you have with precursor only supplements.
Wow. So we'll stay away from the IV. We'll go with the oral pill when it comes to NAD. So before we
And
leave,
I think, probably just key to point out, because I probably sound completely biased, because obviously I have a company that sells a supplement, but, I this is not theory. And I've gone as far as publishing papers on this. So there are, I've published reviews, I have collated all the evidence, all the data that is not us, it's all the other studies that are out there in plain sight for people to see the limitations of all these products. And they, these are peer-reviewed articles. So I think it's important to say that, yeah, we have a product, but it's all backed by the science and that's all peer reviewed. So it's not my opinion.
you're here indeed. So I love to close with, give me 5 reasons why we want to raise our NAD level as a recap.
So firstly, energy. The second thing is better cognitive function and less brain fog. Third is sleep. We haven't even mentioned that, but NAD is so important for sleep. The fourth thing is basically making sure that your cellular health is in good function, the mitochondrial function. Mitochondria are the key to everything. If they're not functioning, bad cellular health. And finally, NAD addresses all of the hallmarks of aging. And up until now, we don't know anything else that does that. So it's a really good place to start.
Without question, a medicinal pathway that gives a great longevity outcome. Dr. Nichola Conlon, thank you for taking your time. We've got to do part 2. Look forward to seeing you again across the pond. Have a great day. Thanks for your time.
Thank you so much.